Hi all, welcome back. Now in part A we were asked to find the combined area expression for the two figures with a total perimeter of 30 centimeters. Now the last part of the question reads, find the lengths that must be cut if the area is to be a minimum. Okay, I'm enunciating that because once you see maximum or minimum in calculus, your mind immediately goes to differentiation, because remember, maxima and minimum, when we're doing maxima and minima problems, when you are sketching your graphs for maxima and minima problems, to find those turning points, the local maximum or the local minimum turning point, you had to take the derivative and let the derivative be equals to 0. The reason why you do that, remember that the derivative basically means that it is your average gradient. It's your tangent, okay, at where the graph touches the circle only at one point. Now at the turning point, your tangent will be a either your tangent will be equals to 0, because your tangent will always be horizontal, and the horizontal line, the gradient of a horizontal line, is equals to 0. That's from analytical geometry as well. Okay, just cross curriculum, bringing it back in here. So once you see maxima or minima, think back and think, oh, they want me to take the expression or the equation and differentiate the equation with respect to a certain variable, and you let that derivative be equals to 0. And then you can find the dimensions or even the point where that local maximum or minimum occurs. So same thing here, same but different. Find the lengths that must be cut if the area is to be a minimum. Now we've proven that that's going to be the combined area for these two shapes there. So we want now to find the dimensions that will make these two shapes to be a minimum. Right, cool. What does it mean to me and you? It means I must let the derivative of a with respect to x be equals to 0, then find my dimensions of x. Let's do it. So here what we had was that expression there. So what I'm going to do, folks, I am going to differentiate that. I can use the quotient rule with that, but I choose not to. It's just going to be too complicated and everything. So what I'm going to do is I'm going to divide everything first by pi, divide all the terms by pi. It's simpler that way, and you will know what you are doing. Divide everything by pi. So your a total can still be rewritten as 4 plus pi divided by pi, that's x squared, plus 225 divided by pi minus 60x divided by pi. Now I can take the derivative of that. dA total or combined dx will be equal to, remember that this is a constant, this is just a number if you like. So you are differentiating with respect to x. So the derivative of this will just be 2 times 4 plus pi over pi x plus, again, this is a number, so the derivative of a constant is equals to 0, we know that. So plus 0, okay, minus, now 60 over pi is a number, 60x over pi, if we differentiate that, that's the same as 60x over pi. The derivative of 60x over pi is just 60 divided by pi. You have to let this to be equals to 0 to find your maximum or minimum dimensions. So if we do that, we get, okay, because of space, I'm just going to write it there. So derivative, that derivative there, and you let it be equals to 0, that's what you would get. Righty then. So how best to solve this? Let's see. I can divide everything by 2 first. Dividing with everything by 2 first, we get 4 plus pi divided by pi x minus, so that divided by 2, the 2's divide to give you a 1. 60 divided by 2 is 30 over pi, and that is equals to 0. I can multiply everything by pi next, both left and right hand side, to give me 4 plus pi times x minus 30 is equals to 0 times pi, which is just 0. Remember, you always multiply both sides, right hand side and your left hand side. We are wanting to find dimensions of x that will make this to be a minimum, and hence we want to find how much each length should be to make this to be a minimum. Okay, so right, so I'm gonna add 30 on both sides of the equation. If I do that, adding 30 on both sides of the equation will give me 4 plus pi x is equals to 30. Lastly, divide both sides by 4 plus pi, which gives me my x as 30 divided by 4 plus pi. This is the x that will give me a minimum area or minimum combined area. If you work this out and you put your 4 plus pi, though, your 22 over 7, or your pi from your calculator, you will get that this x works out to be 4.3, 4.1, 4.2, average 4.2 centimeters. What does that mean, folks? It means that that x there, for this to be a minimum as possible, so you are not wasting wire or wasting material, your x has to be 4.2, 4.2, 4.2, and 4.2 as well. Okay, and then if you work out this area, this perimeter, then if that's 4.2 plus 4.2 plus 4.2 plus 4.2, you will get that the perimeter of, or the total length of the square must be equals to 4.2 plus 4.2, 16.8 centimeters. And the total length of the circle must be equals to, there are two ways you can do this one. You can either, the total length of the circle, you can either take it from 2 pi r, multiply, substitute in your pi there as that expression there, but you don't want to do that. That's just going to be too long. You know that the total length that you were given was 30 centimeters. So you take that 30 centimeters and you subtract from it the total length of the square, because look, this and that add up to 30 centimeters. So we found this to be 16.8 centimeters. So what remains to be added from the circle to give you that 30 centimeters? Think of it that way. So that's going to be 30 minus 16.8 centimeters. What's that going to be? 13.2, 14, 13.2, which is equals to 13.2 centimeters. So this is the big ticket item. This is what is for marks. That's what they were needing. 16.8 centimeters for the square and 13.2 centimeters as the perimeter for the circle. Thank you, guys. That was the last part of that question.